next topic is the normal distribution, which is a very big topic and very important for statistics. Now, the shape comes from if you have a symmetric histogram that looks like this, and you draw a curve on the top to represent it. The curve looks like this. So the normal distribution is sometimes called the bell curve because it kind of looks like a bell. And sometimes it's also called the Gaussian distribution. So the normal distribution is symmetric about the center. And in a normal distribution, the mean, median, and mode are all equal. Many things in life are normally distributed. So human height, shoe sizes, rolling of dice, and many more. Next we have the empirical rule, which is sometimes called the 68, 95, 99.7 rule. And what this says is that in a normal distribution, approximately 68% of the data falls within one standard deviation of the mean. Approximately 95% of the data falls within 2 standard deviations of the mean, and approximately 99.7% of the data falls within 3 standard deviations of the mean. So you can see that displayed in this diagram right here. Now I want to talk about where the inside percentages come from. So if you take the 68% in the middle and you cut that in half, or you divide it by 2, that's equal to 34. So that's where we get the 34s from. Next, if you subtract the middle 68 from the 95, then you get 27. And then divide that 27 by 2, you get the 13.5s. If you subtract the middle 95 from the 99.7, then you get 4.7. And if you divide that 4.7 by 2, you get 2.35. If you subtract the 99.7 from 100%, you get 0.3. And if you divide 0.3 by 2, then you get the 0.15. And then finally, if you add up all of the inside percentages, they add up to be 100%. Now, data that is more than 2 standard deviations away from the mean is considered unusual. So this is the 5% of the data that is outside of the middle 95%. The prices for a model of a car are normally distributed with a mean price of $17,000 and standard deviation of $500. Use the 68, 95, 99.7 rule to find the percentage of buyers who paid the following. Show your graph. So I've already drawn the normal distribution here. That's from here. And all that's left is to label the mean as well as the standard deviations. So my mean is 17,000. So that goes in the middle. And then the standard deviation is $500. So for every line to the right, I need to add $500. And then for every line to the left, I need to subtract $500. So part A says between $16,000 and $18,000. So between here and here is 95%. Part B says between $17,000 and $18,000. So that's between here and here, which is these two regions. So I want to add up 34% and 13.5%, which gives me 47.5%. Part C says between 16,500 and 17,000. So that would be this region, which is 34%. Part D says more than 17,500. So that would be all of the regions to the right of this number. So these three regions. So I need to add 13.5 plus 2.35 plus 0.15, which is equal to 16%. Part E says more than 18,000. So that would be all of the regions to the right of 18,000. So I want to add 2.35 and 0.15, which is 2.5%. And lastly, part F says more than 18,500, which would be 0.15.